Yeah, hello. Good day to everyone. So my name is Dr. Yasir Bashir and I'm a lecturer in the School of Physics. So today we will be learning about seismic reflection data processing. So it is based on a project which is called Tutorial A and it is for the class of Geophysics 2G015. So before we proceed to the processing software, I want to give you an introduction of seismic data acquisition, then followed by seismic data processing workflows, and then I will show you some of the example from the seismic data which is acquired in the field. So first I will tell you about the seismic data acquisition. So for the sake of simplicity, we are considering only 8 channel record, which is a land survey. I will show you an example over here. So here you can see this is a source interval is 1 into picket interval, and we will be using symmetric spread. So in symmetric spread you have similar number of receiver both side of the source. So let's say this is a surface over here and this is your reflector. So source is placed in the middle of the receiver. So these are 4 receiver on the left side and 4 receiver on the right side. Once we fire this shot, so you can see the wave propagate like this and reflect back from here. So this place over here, which is the reflection point, is called CMP, common midpoint. So similar thing will happen because the wave divergence is spherical and every direction the wave will propagate, so it will reflect from this point, and similar thing will happen from all these four for all these 4 receivers. Then what we will do, we will record the common midpoint. So these are the common midpoints number. Then what we will do, we'll move our source and receiver to the next place. So over here it's moved to the right, then fire the shot. So again the recording will happen and the receiver will receiver will record the signals. Then we will pinpoint the CMP over here to calculate the fold. The same thing will happen again for the third shot point, fourth shot point, fifth, and so on. So over here we are showing you, let me make it bigger. So now we can calculate the fold. So the fold is equal to 1/2 C is a C into delta x over delta G. Delta x over delta S is equal to 1/2. 8 is our channel, number of channel, and 50 meter is a picket interval. And again the delta x is 50 and our geophone or the source receiver interval is 50 and source interval is also 50. So we can see the maximum fold recorded is 4. So how many times a CDP is hit by a point is called the fold. So now the second is a split shooting with the picket interval 2 into picket. It's 2 picket interval. So let's say we fire the shot and this wave goes into the subsurface and hit back from the reflector and record to the receiver. So we will record the common midpoint here. Then same thing will happen for the second shot and so on. So over here you can see our source is moving from here to here, so it's mean the picket interval is 2. So in this case our fold is minimum. So let's say this is a 2 fold data, so we can calculate based on our acquisition geometry. And the third type of shooting is end-on shooting. So over here you can see source interval is 1 into picket interval and it is asymmetric spread or volume. So from, let's say if you have a transaction zone like in the seaside, or it's a boundary condition that you cannot acquire the survey on the other side of data, like it's a vegetarian area or vegetable area. So then we have to start from here. So then once we move our source here, then we will put a receiver here, and same thing will happen on the right side. So once we finish our survey from this side, then we will remove our receiver from here, and our shooting will be here. In this case, our fold is maximum. So out here you can see this is 4-fold data. So in split spread shooting, it's a symmetric spread, it's a 4-fold data. In shooting, asymmetric spread is also 4-fold data. But here you can see your maximum taper zone, or taper zone is smaller than in this area. So the no fold area is more than here. So we prefer this type of survey. So just the example of picket interval and geophone interval, source interval. So you can see this is a receiver interval. We can calculate. This is by source interval, which is 2 into receiver interval, and the picket interval is normally it is called the receiver interval. And another thing I want to tell you, the CDP interval is half of the picket interval, CMP interval. So another thing, picket number, which is called the receiver number, and CDP number is equal to picket interval into 2. Normally we assign this CDP number double than the picket interval. So first CDP number is equal to 2 into RP plus SP minus RP1. So this was all about the data acquisition. So we learn about 3 types of survey, which is split spread, end-on shooting, and asymmetric spread. So now we will move into the seismic data processing. So in seismic data processing, we have the mechanical processes and seismic data forms, and the second process is called the interactive process, and third one is the basic processing flow, and another thing we'll discuss about the detailed processing workflows. So in mechanical processes, we have no change in the amplitude, frequency, or phase of the data. So the mechanical process is include demultiplex, which is from the multiplex data to demultiplex. We change from the short order to trace order data, and then we sort our data, then we stack. So in this case, we are not changing any amplitude and phase frequencies. So as I mentioned, the multiplex data is in the short number or the trace sequential data. So we have recorded our data in this form. Each point is assigned by the source and receiver. But now demultiplex, or we have to change into trace sequential data from row into column. So like this, we will change our data from row into column, which is a trace sequential data. So, or we can take the transpose of the data. So this is our distance and this is our time. Then if we talk about common depth family of CDP order data, So before we do the stacking, we have to do the NMO correction. So this is, you can see the move out is like this. Once we stack our seismic section, before we apply the NMO correction, or then we do the stacking. So this all data will be stacked into one trace. So this second one is a interactive processes, in which what we are doing, we doing the trace editing. I will show you in the software what we are going to do. So bed trace smooth, polarity reversal, and kill record. Then we will be doing the first break picking, which is essential for static correction. Then third thing what we are going to do is a velocity picking. It's called NMO correction, normal move out, or dynamic correction as well. So let's compare with the interactive and mechanical processes. So we have two type of processes, as we discussed, mechanical and interactive process. So in mechanical processes, which is highlighted with this green triangle, so demultiplex, sort, and stack is mechanical process. But if we talk about the interactive process, which is a geometry, quality control editing, and static correction, normal move out, or in this flow, it's called the interactive processes. So let's talk about the simplified processing flowchart. So as I mentioned, the data recorded in the field is a short order data. Then we do the demultiplexing, and short order data we will change into trace sequential data. Then we define the geometry. We do the editing of the traces, and based on the geometric spreading, there's a lot of filter we can apply, which is called the notch filter. Notch filter is usually used for certain band of frequency, and then we can also apply the band pass filter and apply the deconvolution operator. And deconvolution operator is used to enhance signal to noise ratio. And then we sort our data. In this, we also, from the geometry, we do the subsampling and first break picking for reflection static, and that reflection static can be updated in the data before applying the NMO correction. So after NMO correction, we can do stacking, that is the output of the raw stack over here. And also from the static correction NMO, we have the CVA, which is during the velocity peaking, and velocity peaking can be resultant from the normal move out. Then we can do the stacking, which is called the brute stack. Then also what we can do is, from before brute stack, we can go to the residual static update, and also the input from the velocity peaking, we can do the NMO correction. Then we do the final stack. Then final stack will go for migration, and final migration will be done for migrated stack. Sorry. Okay, now we move on to the short gather data, and also called the short record or the field monitor data. So I will show you some of the examples from the short gather data which is recorded in the field, so just to get the experience how the data look like. So this is the first example of the data which is recorded in the field. So here you can see lot of noises, refraction, reflections, head waves, ground rolls, ear waves. So these are normally your noise. This is ground rolls, ear waves, but these prominent reflection is from interpreted sediment, and this is water table or head waves, and this one sharp reflection can be associated with volcanic sedimentary interbedded rocks. And this is the second example with the shot here and receiver on the both side. So over here you can see airways, ground rolls here, airways, reflection, this on reflection, and this is the first break, and this is mostly the noise area over here. And here you can see the frequency content of the shot. So here is a low frequency, you see the seismic waves, but the amplitude is quite high, and normally the noise is a very high frequency noise. So here you can see the vehicles are very close. Here is one of the section which is together with a lot of noises. So over here you can see this part is a noise, this one over here and also here. So this is quite difficult to interpret, but before we going to do the interpretation or processing, we need to take this challenge to remove the noise first, then do the processing. Still we can see the reflection here. This is the first break, this reflection, airwave, ground roll. So first arrival, reflection, ground roll. So as I mentioned, after the processing, you can see noise removal. The first break is very clear. First arrival, then reflection, and the ground roll. This is before. After. So this is a short gather data with the add-on shooting. So this is with the add-on shooting which we are talking about. So you can see the sources on this corner and receiver is here. So our survey is moving like this. So this is split spread shooting. Over here you can see quite good data. And this one is split spread with one phase of the shot. So over here you can see these traces are quite unusual or unexpected. So during the editing during the seismic data processing, we can edit this trace or we can kill the trace, because this is because of the noise or some other or incoherent noise. So after the killing or editing, we can remove these traces and replace with the beside traces. And also we can remove this type of event by muting this part. This is called the airwaves. And also we can remove from the top or base, top mute, base mute, and surgical mute as well. So this is CDP gather data before NMO correction. You see the move out of the reflection, but after the NMO correction, the move out. CDP gather can be seen and the move out is correct. So this was the first part of the presentation, and so we have some idea about the seismic data acquisition, what type of acquisition we are using in the field, and the general and very simplified seismic data processing workflow we have seen, and some of the example for the seismic data processing such as muting, signal to noise recovery, and also some part trace editing we have learned about that. And some of the data example I have shown you from the split spread geometry as well as from the add-on shooting geometry. So after this we will move into using the software, which is a seismic data processing software. So in the folder which is provided to you is called processing software, and in which you can see and run the software, and you can follow my second video for using the software.